Okay, well, welcome back. And what we're going to be talking about is check your understanding of 1.1a. And 1.1a, we're talking about displays and how to create accurate displays, and also talking about some two-way tables and whatnot. So we're going to go through and check our understanding on doing this. So if you have a problem like this, or you want to go through the problem, please pause the video, try the problems first, and then press play again. Okay, so start off, we're going to look at problem number one. Problem number one is basically we have a display, and it says students at a local high school were asked whether they preferred PlayStation 3, which probably nobody wants because it's a dated problem, or Xbox 360, or neither. The graph shown on the right shows the results. Explain why the graph may be misleading. Well, the graph, if you see this right here, looks like that everybody prefers PlayStation. All right, by very large margins, because you see this huge gap from here to here, and if you take a little closer look, you realize that, hey, that gap is not really that wide. It's actually just 3%. 3% differential. Why does it look so wide? Well, the first thing is that when you're talking about bar graphs, you always want to have your scale start at 0. And so we're going to write here is why it's misleading. The scale does not start at 0. That's the first thing. All right. We realize that scale does not start at 0. And so the other thing is that not only does the scale not start at 0, but also the pictorial graphs of the two different PlayStation gaming systems, they are different. All right. This is a little bit wider than the Xbox 360, so it looks like this is maybe larger. And so the size of the bars that used should just be bars, and they should be about the same widths going throughout. And so the pictorial graph of the gaming systems is also misleading because of the different sizes. I'll just put that, different sizes. Okay, so that's why you really want to avoid pictorial graphs whenever you're doing different things like that. Okay, so the 0 scale, not good. Also the size, the pictorial graph, when you're doing that, not good. All right, well, with that, let's go down to the next problem. And what we have here is a two-way table. All right, we have a two-way table. And you can say with this two-way table, you can read through this thing, but really there's an experiment that's being done. And in this experiment, they give 3 different treatments for those that suffer from depression. All right, that's a common thing that's happening. And they give St. John's wort, Zoloft, and placebo to figure out, is there a difference, is there an association between the treatments and what they claim as improvement in depression. So full response means they got better, partial response, and then no response on the change in depression. So with that, let's see what we want to do here. So in this two-way table, you can see that I put in the counts, the frequency margins, okay? Marginal frequencies in each one of these. And that's what's referred to as the margins, okay? So when we look at our first example, our first problem, it says the proportion of subjects in the study that were randomly assigned to take St. John's wort, and explain why this makes sense. Okay, so St. John's wort, we can see that there was 113 people. Okay, so the proportion would be 113. And we're going to divide that by 338. Okay, 338. And if you take that proportion, that is approximately about, all right, 0.33. Okay, 0.334. Notice that when we talk about proportions, I'm going to keep it as a proportion or a ratio or as a decimal. Okay. Now, why does that make sense? Well, they tried to randomly assign at least, since there was 3 different treatments, to try to get about the same amount. So that's about 33%. So each treatment received about 1/3 of the 1/3 of the treatments. Okay. So each of the total amount of people or divided into thirds. So that makes sense. All right. Treatments divided into thirds. All right, in thirds. Okay, so, and that's what we have there. Okay, so next thing is, and that's what we actually call a marginal. All right, marginal frequency. Marginal. All right, proportion. All right, marginal proportion. Now, the next one says, find the distribution of change in depression for the subjects in the study using relative frequency. Now, relative frequency is where we use percents, okay, is where we use percents. And so I'm going to put this on over the side here. So in our two-way table, we're going to figure out what is the percent of each one of these changes in depression. And so for a full response, we're going to have 91 divided by 338. Which is going to give us a percent. Now that's a proportion. And to get the percent, we're going to take 91 divided by 338. You put this in your calculator, and you get about, I'm going to round this to about 27%. Okay, that's our relative frequency. So relative frequency is a percent. The next one we're going to do is we're going to take 13 divided by 338, the total. And when we have that, 13 divided by 338, that's going to give us about 0.04. Oh, sorry, I took the wrong one. 55. I looked at the wrong value. I apologize. Hope you caught that. All right. And so what we have right here is we're going to take 55. There we go. That didn't make any sense. So 55 divided by 338. And then we have about 16%. About 16%. That makes more sense. All right. And finally, we're going to take the margin, 192. Divided by 338. And that's going to give us about 57%. Now, when you take these margins together, these percentages, because we're taking of each one of the change in depression, they should equal to 100%, which it does in this case. You may be a little bit off depending on how you round, but it should be at 100% when you take up all of these different percentages of the margins of change in depression. Okay, so that is known as relative frequency. That is a very important word. So whenever you see that, you're talking about percents, and you find this marginal relative frequency over here. Now, next thing it says, what percent of subjects took Zoloft and, all right, showed a full recovery? Now, the end means we're going to do a joint, right? Proportion, and we're looking for here is Zoloft and had a full response, so it's thinking like 27. So 27 out of 338, which is going to give us approximately 8%. Okay, so about 8% of the people took Zoloft and had a full recovery, and that's what we have there. All right. So, what did we talk about? What we talked about here is how to draw and how to determine if a display is actually accurate. Make sure we always talk about bar graphs. They always have a scale starting at 0. Also, what we want to make sure is that we don't use pictographs that mislead people. So you want to have your bars being the same width, all right, and make sure you label everything like they did there. Also, when we have a two-way table, all right, two-way tables take the information. It's another way of displaying the information. It's dealing with numbers. We have our frequency or counts in the middle. And then on the sides, we can have our marginal frequencies, all right there. And we have then our total of all of these subjects being tested in our data. And then we can have what is known as marginal relative frequency. We have joint relative frequency, and so on and so forth. All right. Well, I hope this helps you out. We're going to go through another chicken understanding in the next video. All right. Good luck and God bless.